So in section 4.4, we're now going to be looking at more solving logarithms and exponential equations. We've solved basic logarithms. We've solved exponential equations with e as the base. Now we're going to look at solving exponential equations with other bases. So the steps for exponential equations are, we're going to isolate the base to the exponent, rewrite the exponential as a logarithm, then solve. So if I have 2 to the x power is 5, well, the 2 is my base, 5 is my number, x is my exponent. So to change this, I would go log base 2 of 5 is x. Now to get this result, I use my change of base formula. So x is going to be log 5 divided by log 2. So on my calculator, on this one I will do 5 log divided by 2 log and then hit equals and get 2.32. So x is 2.32. And you can check. Just take 2 to the 2.32 power and it should give you roughly 5. It's going to be close because we've rounded. Same thing for example 2. I have a base to the exponent equals my number. So I change to a logarithm with my base 4, 35 is my number, and my exponent is x. Use my change of base formula, log of the number divided by log of the base. So 35 log divided by 4 log equals 2.56. Now, in example 3, the difference here is that we have 8 times 3 to the x equals 5. Now, we can't take 8 times 3 because they have different exponents. So we can divide both sides by 8. Now, I can't divide by 3 because, again, the 3 has an exponent, but the 8 does not. So this leaves me 3 to the x is 5/8, or I can make that 0.625 since the decimal terminates. Same thing. Change to a logarithm. So log base 3, 0.625 equals x. Do my change of base, log 0.625 divided by log 3 equals x. And x is negative 0.43. In example 4, only difference is instead of having x, we have a different expression. So we still can change this to a logarithm. And if you're confused or you're having trouble with this, keep in mind that in a logarithm, the exponent, the logarithm equals an exponent. So the exponent's over here, the base is your subscript, and so the number goes here. Do not do 3 to the 7th power, please. That's the mistake students make here. Don't do that. You have a logarithm. So then we do our change of base formula, log 7 divided by log 3 equals x plus 2. So 7 log divided by 3 log equals 1.77. So x plus 2 is 1.77. Subtract 2 from both sides. So x is negative 0.23. The last example here is kind of one like we've done previously. We have our base of e. So we change this to a natural logarithm where natural log 45 equals x minus 1. We don't need to write the base of e there because that's the only base the natural log has. And then we punch that into our calculator. So I get 3.81 is x minus 1, add 1, and 4.81 equals x. Okay, so that's solving your exponential equations. I mean, there's more variations, other things you may encounter, but, these are your basic steps to doing that. Next, we're going to kind of revisit solving logarithms, the basic ones, and then looking at applying our laws to solve our logarithms. So just keep in mind that you want to have the log of your number isolated equals to your exponent, and then we're going to rewrite as an exponential equation and then solve from there. So in this case, my base is 10. So 10 to the 1.2 is x. Put that into your calculator, and I get 15.8 equals x. Solving natural logarithms, only difference is your base is e. So my base is e, my power is 2.3, and that's equal to my x plus 2. So I do e to the 2.3, and I get 9.97 equals x plus 2. Subtract 2, so x is 7.97. Whoops, can't talking right. Now, these next several examples are going to involve using our logarithms because we can't rewrite our expression until it looks like a single log. It's got to be a single log. So what we have to do for this is to use law 1 on the left side. So using law 1 here, I can make this log base 3 of x times x plus 8 is 2. I'm taking what we did using the laws of logarithms, creating a single log. Now I can say 3 to the second power is x times x plus 8. So what I'm going to do now is I'm just going to interchange my sides, and I'm going to continue to solve. X squared plus 8x is 9. Subtract 9 because now I have a quadratic. Factor and solve. Now, with logarithms, we have domain, okay? So we can either look at the domain ahead of time, which I'm going to do on the next one, or after we're done. But at any rate, if I look at my domain of each individual expression here, my domain for this first one, x must be greater than 0. For the second one here, x must be greater than -8. So in order to satisfy both of these, my solutions must be greater than 0. So x is 1 is the only value that will satisfy both of these, that will actually solve. Okay? So kind of what I mean here, if I look at this right here, my domain is x is greater than -6 and x is greater than -2. So to satisfy both of these, I have to choose the larger domain. So x must be bigger than -2. Now I proceed to solve as I did up here. I use law 1 on the left side to make log base 5 of x plus 6 times x plus 2 equals 1. Now I can change to an exponential equation. interchange my sides. So I get x squared, 6x and 2x is 8x plus 12, is 5, because 5 to the first is 5. Subtract 5 from both sides, because I need to solve this. Factor. So x is negative 8 or x is negative 1. But again, in order to satisfy my domain, the only one that can work is the one that's greater than negative 2, which is the negative 1. So that's the solution that I can use. You can do these. They may be difficult, a little bit time consuming, but you can do them. Another one. Okay, same thing. Okay, just lots more practice. So if I look at, again, my domain, for this one, x must be greater than 0. For this one, x must be greater than 3. So in order to satisfy both of them, whatever solution I get must be bigger than 3. So I'm going to take this and apply law 1. Change to the exponential form. Interchange my sides, and then go from there. X squared minus 3x is 4. Subtract 4 from both sides. Factor. Oops. Mess up my high-tech camera here. X minus 4 times x plus 1 is 0. Solve, so x is 4 or x is negative 1. Negative 1 does not satisfy my domain, so therefore 4 is the only solution. Okay, so that's solving logarithmic equations using your laws of logarithms with law 1. These next two examples are involving law 2 because of the subtraction. So these can be a little bit more difficult because of the fraction. So my domain, again, x is greater than 0, x is bigger than 1. So whatever solution I get to satisfy both of these must be greater than 1. So here I will use law 2. So the natural log of x over x minus 1 equals 2.5. Change to the exponential form. Now my base is e. So e to the 2.5 equals x over x minus 1. You know, roughly 12.2 is x over x minus 1. Okay, so it's always, not always, but it tends to be intimidating when we have decimals and the numbers don't look right and all like that. Just, the process doesn't change. Follow the process. Multiply both sides by x minus 1 to clear your fractions. Okay, so that clears the x minus 1s there. So what I have is I have 12.2x minus 12.2 equals just x. Okay. Need to get my x's on one side. So don't let this intimidate you, because this is just 1 minus 12.2. Just put it in your calculator. And I get negative 12.2 equals negative 11.2x. Divide both sides by negative 11.2. And I get 1.09 equals x. Now if we round that to the tens or whatever, it's still bigger than 1, so my solution is fine. So, with these, sometimes you're going to get decimals, sometimes you won't. Don't let that scare you or intimidate you. Just follow your process. Last one, law 2 again. My domain here, even though 3x, it's 3x, it's still my x has to be greater than 0 here. X must be bigger than 2, so that's what I need to satisfy my solution. Log 3, so I use my log 2 to change this from a difference of 2 logs to the single log of a quotient. Change it to the exponential form. Interchange my sides. Now I'm going to multiply both sides by x minus 2. So these go away. So 3x equals 9x minus 18. Subtract 6x from both sides. Or subtract, how about 9x? Minus 6x is minus 18. X is 3. And that satisfies my domain. Okay? So, you know, these aren't the easiest things you'll ever do. But, you know, I think you can handle it. All right? So we will do more of these when we meet again.